Alright, so this video is about when to factor out a negative to help you simplify a problem. Back when we took our factoring test for chapter 7, when we learned all our factoring methods, we had a problem on a test that was 2y squared x minus 1 minus 6y 1 minus x. The purpose of this problem was to look at three different things. One would be the coefficients, then the variables, and then a GCF of a quantity. So what I notice here first off is that I can factor a 2 out of each problem, or out of each expression. I can factor a 2 and a y. But then when I compare quantities here, so this x minus 1 and this 1 minus x, they look awfully similar, and further comparison shows that this is the x over here is positive, this one's negative, this negative 1, and then a positive 1. So by factoring out a negative out of this term, so factor out a negative to here, making it a positive, will change those signs. What does that mean? Well, this becomes x minus 1 when you factor out a negative. Now, a lot of you might think that this changes the problem, and it doesn't, because if I factor the negative back through, I get what I had, so I'm not changing the value. So I can factor now out the 2, the y, and an x minus 1. What's left? Of my first term I have a y, and of the second term I factored out a 2, so I have a positive 3. The y is gone, and so is the quantity, therefore this would be completely factored. Here's a problem with factoring out a negative to help simplify within what we're currently doing. So first off, when I see negative exponents, if they're separated by plus or minuses like this is, I need to adjust the term within the term it's in. So for instance, this first one, I have to simplify to x over y minus 1. And then the bottom will be very similar to the top, 1 minus x minus 1 over y. Now, a lot of students are trying to break this up, and they're changing their fraction bar, and they're using this sign. I don't like that. What I like to do is I like to keep working within the numerator and within the denominator. And before I can multiply by a reciprocal, I like to find a common denominator. So on top, my common denominator is y. So I got to multiply the 1 by y over y. On the bottom, it's x and y. So I got to multiply this by y over y and this by x over x. This top part results in x minus y over y divided by, on the bottom, I get y minus x over x times y. Now that I have one fraction on top and one fraction on the bottom, again over here I had two fractions, for the bottom I had two fractions. Now that I have one fraction, I like to multiply by the reciprocal. This is the best point to simplify. So x minus y over y times x times y over y minus x. So a simplification from diagonally here, this y will cancel with this y. This x has nothing to cancel with. Notice over here, this is x minus y and then y minus x. So by factoring out the negative, this becomes a negative y, this becomes a positive x. So what am I left with? Well, the negative y and x, now these quantities match, so I can cancel out the entire quantity. I'm not canceling out individual terms, I'm canceling out the entire quantity. The negative remains, and I'm left with negative x. That is a fully simplified rational expression. If you have any questions, please comment below or leave within our Edmodo page. Thanks.